Good afternoon, everybody. I'm Ames Hill, plant engineer for Calisonic Kansai. Today we'd like to talk about going forward with oil-free technologies in our centrifugal chiller plants. We defined our project goals when we started looking to replace our centrifugals as environmental enhancements, an ISO 14001 commitment we'd made to reduce or eliminate CFCs from our operational profile, energy efficiency, reduction in maintenance cost, and improved reliability. We started with two centrifugal chillers that were 25 and 28 years old respectively. The existing chillers we had utilized CFC11 refrigerant, which has a high ozone depletion potential. CFC means chlorofluorocarbon. They've been banned as a result of the Montreal Protocol and the resulting Clean Air Act. The existing chillers we had were of the oil-flooded hermetic design, which simply means that part of the refrigerant and oil charge has to be utilized for motor cooling purposes, which can take away from the efficiency of the machine. The existing chillers were single-speed, single-stage compressors. These types of compressors have inherent design limitations that are impossible to overcome. So we reviewed the options. The new traditional centrifugal low-pressure machines out there today utilize HCFC 123, which is an environmentally responsible replacement refrigerant, a lot lower ozone depletion potential, but still the machine operates at subatmospheric conditions, which causes you to have to maintain a purge unit to remove non-condensables that may leak into the system as a result of the subatmospheric condition. Also, this machine is still an oil-flooded machine, which requires maintenance and associated expenses with regard to oil sampling, oil changes, disposal of waste oil, handling and storage charges that go along with the ownership of this type of machine. So, time to replace the chillers. As I said, we've made an ISO 14001 commitment to eliminate CFCs from our operational plan. The mean time between failure rate for these existing machines had reached a point of unacceptability. Repair cost had escalated. We knew there were a better use of our resources than continuing to throw money at these old machines. Additionally, tax incentives were available through the U.S. Department of Energy to help offset some of the cost of acquisition for the new equipment. We elected to make an investment in technology. The new oil-free centrifugal chiller technology uses multiple compressors with inverter-driven permanent magnet motors with magnetically levitated bearings. These bearings cause no metal-to-metal contact, resulting in zero friction and no need to add oil for lubricity. They utilize a DC motor with an integrated variable speed drive. The new motor efficiencies are in the range of 97%, and the compressor tip speeds run anywhere from 18,000 to 48,000 RPM, depending on where they're running in the load curve. Efficiency through technology. The overall efficiency is affected by the compressor's isentropic efficiency in the motors and the bearings. This basically means the fewer moving parts you have, the more efficient the machine. Friction losses are reduced through the use of magnetic bearings. Again, no friction, no rob of efficiency. Startup current is reduced down to 2 amps as a result of high-speed, high-strength, lightweight composite materials being magnetically levitated, which requires far and away less starting torque to get the whole mass moving. We've seen reduced transients on our power grid, and our demand penalty charges from our utility company have been eliminated. Capacity to demand. Multiple compressors being driven with VSDs ensures that capacity is matched precisely to load. All this is basically saying is that on any given day, under any given circumstance, we're not making a single ton more of chilled water capacity than what the demand in the plants are using. This allows us to eliminate lots of waste from our operational profile. Each of these compressors utilizes 2 stages of compression with economizer cycle potential, which means simply that when the outdoor conditions will allow for it, the machine will go from an air to water exchange to an air to air exchange, which allows us to basically free cool the buildings. The IPLV stands for integrated part load value. We're down to about 0.37 kW per ton rated of potential for our IPLVs. This is important because most chillers operate anywhere other than at 100% of their demand design. Part load value is the efficiency standard that matters. This number represents about a 68% reduction from what we started with. Reliability. Obviously, in a manufacturing environment, downtime is hugely expensive. We can't afford to not ship parts to our customer. Chiller repairs are also expensive. These compressors utilize impellers that are keyed directly to the rotor, resulting in a single moving part, which reduces the internal complexities of the machine, eliminating the failure potentials. The additional benefit to this type of machine is that having multiple compressors affords machine-level redundancy, so should you suffer a failure on any given compressor on the machine, it's invisible to your internal customer. You can keep running with the remaining compressors while sourcing a replacement or repair for the failed component. Control capabilities. These new chillers are able to respond to variable primary flow pumping characteristics that we utilize now with our modern pumps. The old chillers would not handle this resulting variations in flow. The new chillers are able to be easily integrated via protocol converter into our existing building management system. This is important to us because we operate multiple facilities across multiple states and even down into Mexico. By having these chillers integrated into our building management systems, we can have supervisory control, measurement, and monitoring from a single seat anywhere within our corporate structure. Another thing we found when we started doing the design review was that the original engineer of record had oversized the chillers with regard to the building demands. We removed two 500-ton machines from each location and went back with a single 650-ton machine. This is a 35% reduction in tonnage with no reduction in capability. We've reconfigured all our pumping and added VFDs to our operational profile to ensure that we're getting maximum holistic system efficiency across the entire spectrum of our demand curve. More to follow. What we're looking at now is cooling tower enhancements, higher efficiency pumping, and airside improvements which allow us to better deliver the finished product to our internal customers in the plants. Again, it's all about eliminating waste. We don't want to produce a single extra CFM of air, or GPM of water, or ton of refrigerant than what our plants actually require. If you're not using it, it needs to not be produced. That's our mantra. Anybody have any questions or comments? I'd be happy to take them now. If not, thank you for your time, and I hope you enjoyed that.